This video is on the objective, make a conclusion and interpret the results for testing the difference between two means, and this is with the population standard deviations unknown. Okay, so that means you're eventually going to be working with the student's t-distribution. And this is using the critical value / rejection region approach, or just the critical value approach. Alright, now I've already done a video on this objective. This is number 2 here, so hopefully you've watched that one. This one's going to be pretty similar. And it's just really a matter of, does your test statistic fall in the rejection region or not? The rejection regions that are identified or defined by the critical values. If it does, you reject. If it doesn't, you don't reject the null hypothesis. And then based on that decision, what kind of conclusions can you make about the initial claim or about the alternative hypothesis? Alright, so again, if you're unfamiliar with the topic, want to see more about what they're showing you, click on More Instruction, look at their notes, their videos, their examples, and hopefully those help you. Alright, so here's the question. Mariana is a website designer who wants to determine whether two homepage formats leave visitors to click on a different number of links. So she writes 2 scripts, one to randomly display one of the home pages and another to record the page displayed and the number of links clicked. For the sample for homepage A, the 132 randomly selected visitors clicked an average of 8.7 links with a standard deviation of 2.3. For the sample for homepage B, the 118 randomly selected visitors clicked an average of 7.3 links with a standard deviation of 2.1. Alright, so here let mu1 be the population mean number of clicks for homepage A, and mu2 be the population mean number of clicks for homepage B. Now it says that Mariana uses the alternative hypothesis mu1 minus mu2 is not equal to 0. So this is the statement that these two averages are not the same. Right. And this would be a two-tailed test, right? If it's not equal to 0. If it was greater than 0, it would be a right-tailed test. If it was less than 0, it would be a left-tailed test. And this assumes the sample standard deviations are equal, right? That's the null hypothesis. The null hypothesis would be assuming that mu1 minus mu2 equals 0. And Mariana sets alpha to be 0.01, right? So 1% significance level using 248 degrees of freedom. So again, this is one of those pooled scenarios. Because these are both about the same thing, these are both about website traffic, homepage traffic, for these two kind of similar home pages. So she's assuming here that the population variances are equal. And remember, in the pooled scenario, the number of degrees of freedom for your t-distribution was, the sum of the sample size is -2, and you see 132 plus 118 is 250, -2 would be 248. So they don't, without saying it, they've given us a pooled scenario here. And they tell us the test statistic. If the t-test statistic is 5.01 and the rejection regions are less than negative 2.596 is one critical value, like the left critical value, and greater than positive 2.596, the right critical value, what conclusion should be made about the population mean number of clicks between the two home pages? Identify all of the appropriate conclusions. So you're going to pick one of these first two and then one of these second two. You're going to select all that apply. All right, so again, I'll go to a piece of paper, write down the information we're given here. Now the null hypothesis, right, what we'd be assuming to be true is that the difference between these population means is equal to 0. Right? Assume that there's no difference between these the traffic, the number of clicks that each of these home pages get. The alternative hypothesis is going to be that the difference between these two means is not 0. And if it's a not equal, that's a two-tailed test. So there should be two two rejection regions, one on both ends, and two critical values. This was a t distribution with, they said 248 degrees of freedom. I'll draw a picture. The horizontal axis represents t-scores. It's bell-shaped, symmetrical, kind of like a normal, right? But it's a student's t. Underneath the peak is a t-score of 0. And then they gave us these critical values. Now alpha, right? Alpha was 0.01, right? So the area of both the rejection regions put together need to be alpha, right? Need to be 1%. So that's why they have the 2 here, right? Two-tailed. The area of the right tail rejection region and the area of the left tail rejection region put together need to be 1%. So that's why each of these areas is 0.5%, right? 0.005. Same thing over here, the area of the left rejection region, 0.005. And that's why they gave us this t 0.005, right? The t-score with 0.5% above it is a 2.596, right? And the same thing over here, they give us the opposite of t 0.005 is negative, 2.596. So those were the critical values. All right, and then they told us, before that our test statistic, right, for the difference between the sample means of the two samples she took, or Mariana took, the test statistic came back as 5.01, which is over here, right? 5.01. Right, there's the test statistic, which is clearly in one of these rejection regions. All right, if it ended up being between negative 2.596 and positive 2.596, then we wouldn't be in a rejection region and not reject the null. But here the test statistic is clearly in one of these rejection regions, right? So we are going to be rejecting the null hypothesis. And so I'll put a big X through it. Meaning, now if we're rejecting the null hypothesis, that means we're leaning toward the other one, right? We're going to be accepting the alternative hypothesis. And this is a statement that the two mean values are not the same. All right, now let's see how they word things and see which one has us supporting the fact that they're not the same. So I said, again, we reject the null hypothesis. Now this first statement here, the third one down, there is insufficient evidence, right? There's not enough evidence at this 1% significance level to conclude that the population mean number of clicks from homepage A is different than the mean number of clicks from homepage B. Well, no, that we said we are supporting that. We are saying that, right? If I rejected the null, that they were the same, that means we're accepting the fact that they aren't the same. We're supporting it. We'd say there is enough evidence at this significance level to say that they aren't the same, that they are different. Again, please read through your answer explanations. And again, hopefully watching this and looking at the more instruction and reading your answer explanations, hopefully all this stuff helps you when you work on this stuff on your own. And thanks for watching.